Welcome to aminacademy.com. In astronomy, let us discuss about the structure and composition of the sun. Our sun is a 4.5 billion year old yellow dwarf star, a hot glowing ball of hydrogen and helium at the center of our solar system. It's about 93 million miles, nearly about 150 million kilometers from Earth, and it's our solar system's only a star. Without the sun's energy, life as we know it could not exist on our home planet. The sun may appear like an unchanging source of light and heat in the sky, but the sun is a dynamic star, constantly changing and sending energy out into space. The science of studying the sun and its influence throughout the solar system is called heliophysics. The sun is the largest object in our solar system. Its diameter is about 1.4 million kilometers. Its gravity holds the solar system together, keeping everything from the biggest planets to the smallest bits of debris in orbit around it. Even though the sun is the center of our solar system and essential to our survival, it's only an average solar star is terms of its size. Stars up to 100 times larger have been formed, and many solar systems have more than one star. By studying our sun, scientists can better understanding the working of the distant stars. The hottest part of the sun is its core, where temperature is top about 27 million degree Fahrenheit. That means 15 million degrees Celsius. The part of the sun we call its surface of photosphere is relatively cool, that is 10,000 Fahrenheit, nearly about 5,500 degrees Celsius. In one of the sun's biggest mysteries, the sun's outer atmosphere, the corona, gets hotter the farther it stretches from the surface. The corona reaches up to about 3.5 million degree Fahrenheit, much hotter than the photosphere. Now let us discuss further detail about composition of our sun. The sun is primarily composed of hydrogen, that is approximately about 71 percentage by mass, and helium approximately 27 percentage by mass, with trace amounts of heavier elements. Its structure consists of several distinct layers, including the core, radiative zone, convective zone, photosphere, chromosphere, and corona. We will discuss about the composition of the sun. Hydrogen, the main fuel for the sun's energy production through nuclear fusion. Helium, the product of a hydrogen fusion accumulating in the sun's core over time. Trace elements like oxygen, carbon, neon, and iron exist in smaller quantities. Layers of the sun. The sun has 7 distinct layers categorized into the inner layers like core, radiative zone, convective zone, and the outer layer, photosphere, chromosphere, transition region, corona. This is the layers of the sun. These layers are differentiated by their temperature, density, and the way they transport energy. The core, the innermost layer where nuclear fusion takes place, converting hydrogen into helium and releasing tremendous energy. Radioactive zone, energy from the core is transported outward through the radiation. Convective zone, energy is transported outward by convection, where hot gas rises and cooler gas sinks. The photosphere, the visible surface of the sun, where light and heat are emitted. This is the photosphere. Chromosphere, a thin layer above the photosphere characterized by spicules and prominences. This is a chromosphere. And corona, the outermost layer extending millions of kilometers into space with extremely high temperature. What are the solar activity? The sun's activity, including sunspot flares and corona mass ejections, is linked to its magnetic field and the movement of plasma within its layer. Solar activity refers to the dynamic and variable behavior of the sun, driven by its magnetic field. It encompasses phenomena like sunspot, solar flares, corona mass ejection, CMEs, and solar wind. These events can impact space weather, affecting satellites, communication system, and even power grids on Earth. So far, we discussed little about the, the structure and composition of the sun. We have done. Please subscribe our YouTube channel.